In this lesson, we're going to talk about some of the basic types of factoring. Here's our general strategy for any type of factoring. When we're given a polynomial, the first thing we want to look for is if we can factor out a greatest common factor. Once we've determined if there's a greatest common factor, we could take that out. And then after that, we need to see if the polynomial we're left with can still be factored further. So we're going to look at the number of terms to help us which direction we should continue on with our factoring. Okay, in this particular lesson, we're going to look at factoring out the greatest common factor, and we're also going to look at factoring by grouping. Okay, so factoring out the greatest common factor, essentially this is just the distributive property in reverse. So we're going to look at all our terms and we're going to determine if there is a factor that's in common to all of the terms that we have. So my first example here, I have 8x to the fourth minus 4x cubed plus 10x squared. Let's first look at the coefficients. We have 8, we have 4, and we have 10. So what number is going to divide all three of those numbers evenly? If you said 2, then you are absolutely correct. After that, we can look at the variable. We have x to the fourth, x cubed, and x squared. So again, what is the largest number of x's that we can take out evenly in each term? We could take out x squared. Okay, when we're taking out a 2x squared, again, we're just doing the distributive property in the reverse. So it's like we're dividing out 2x squared instead of multiplying, which is what the distributive property has us do. So when I divide out that 2x squared, I'm left with 4x squared minus 2x plus 5. And this is my factored polynomial. Remember, we could always check our answer by distributing. So 2x squared times 4x squared is 8x to the fourth minus 4x cubed plus 10x squared, which is what we were originally given, so that checks. Okay, we're going to do the same thing for the next two examples. So here, if I look at my coefficients, I have 1, 3, and 5. Well, there's no numerical coefficient that is going to be my greatest common factor. Really, the only number that will divide each of those numbers evenly is 1, so we don't even need to write that. Okay, let's look at the variables. So I have x's and I have y's, so let's first look at the x's. X cubed, x to the fourth, x to the fifth. The largest one that can be taken out evenly is going to be x to the third. Y squared, y, and y cubed. Again, the largest number of y's that I can take out evenly is just going to be the single y. Let's look at what's left. I'm left with a y in the first term plus 3x in the second term plus 5x squared y squared in the third term. Make sure when you factor out your greatest common factor, inside of your parentheses you have the same number of terms represented, which I do here. Again, if you want, you can check it. X cubed y squared plus 3x to the fourth y plus 5x to the fifth y cubed. And again, that checks. Okay, last example. It looks a little bit different than the previous two. Okay, what is in common? Let's look at our terms. I have this first term and the second term. Okay, we see that there's an x minus 3 in common. So I'm going to factor that entire x minus 3 factor out of both of my terms. What am I left with? 5x plus 6. Okay, even though this looks like a little bit of a different example, this is actually what we're going to see when we start factoring by grouping. So next is we're going to look at how many terms are left over. So if I could factor further or if there is no greatest common factor. Okay, so we're going to look at when there's 4 terms, can I factor by grouping? Okay, factoring by grouping means that we're just using the associative property to group the first 2 terms and last 2 terms. Then we're going to factor each of these groupings separately. A lot of times when we factor by grouping, we have 4 terms in our expression. Okay, so again, it's going to look very similar to this example right here. That's going to be kind of like the step before our answer. So we have 3x squared minus 2x plus 12x minus 8. Okay, so we're going to use the associative property to group the first 2 terms and the last 2 terms. I think the book uses parentheses. I like to just kind of split it right down the middle. Okay, the reason why is sometimes when there's too many parentheses, it gets a little confusing. But if you want to use parentheses, you can do this as well. Okay, we're going to look at the first 2 terms. What is the greatest common factor of those first 2 terms? It's x. What are we left with? 3x minus 2. Okay, second 2 terms. What is the greatest common factor? We have a plus sign there, so I'm just going to bring that down. And I have a 4 that's in common. 3x minus 2. Again, notice there's my 3x minus 2 and my 3x minus 2 in common. That brings us back to factoring out a greatest common factor. 3x minus 2 times x plus 4. Again, make sure you look at everything that you're left with and that it's factored completely. And everything here is factored completely. Okay, next example. Again, if you don't like to draw the line down the middle, you can use a set of parentheses instead. First 2 terms, what is the greatest common factor? X, and we're left with x to the 4th plus 1. Minus sign comes down. What is the greatest common factor in the second 2 terms? 2. What are we left with? X to the 4th minus 1. Excuse me, plus 1, because I factored out that negative sign. X to the 4th plus 1, x to the, so I can take out an x to the 4th plus 1. I'm left with x minus 2. Last example, again, I like to just split it down the middle. It makes it easier for me, so that's what I'll do in this example. Okay, first 2 terms, x cubed can be factored out. We're left with x squared minus 3. Okay, second 2 terms, a negative 2 can be factored out. I'm left with x squared minus 3. So I have x squared minus 3 times x to the 5th minus 2.